All right, everybody. Today we are going to demo how to understand and how to make our own scatterplots. So a scatterplot, as shown, you have two different examples here shown, is a graph that's used to determine whether there is a relationship between paired data. And when we say paired data, if you think of the word paired, like an ordered pair, right? So paired data meaning a paired x and y value. And in this case, for instance, we have an x value here of kilometers run per week versus a y value of your weight. Okay. For instance, here we have temperature in comparison to sales, right? So talking about ice cream sales here. So notice the idea here is to check if there's a relationship between temperature and sales or the kilometers you run per week versus your weight. Okay. So again, you're checking for the relationship between them. So what that looks like is collecting data, right? You're going and you're saying, all right, let me go ahead and look at one specific day, check out the temperature and how much ice cream sales were made. Let me go ahead and do it for another day and collect it. And you collect a bunch of that different information, likely on each a different day, and you plot that information. So we might be graphing some of these from a table, and you can see. So from here, this looks like there's a relationship, right? So down here, the temperature was pretty low. Lower. That's still like 93. And we only sold about $60 worth of ice cream. We go up here 100 degrees and we're selling like 80 degrees of ice cream. And then it's 105. Man, here in this instance, much higher. We're selling 110 or 112 dollars worth of ice cream on those days. So you can see as the temperature increases, the sales seem to increase. Let's take a look at this one. Right here, it looks like the more kilometers that a person runs, likely, like per week, likely their weight is lower, right? Obviously, these are not always the case. So you can see here, it looks like, for the most part, like I said, the more you run, the lighter people tend to be. However, that's not always the case, right? This person right here, this one ordered pair, again, likely one person, they run about 7 kilometers per week, yet they're still heavier than the other people in this study. And this would be considered an outlier, but you can see, it happens, right? These are all different ordered pairs. They represent different people, okay? It's no longer a function that we're graphing it. Everything's gonna be on this one line. It's gonna kind of be all scattered all over the place, hence why it's called a scatter plot. So these relationships that we're looking for have titles, right? What we refer to them as. So we refer to them as being a positive correlation or a positive relationship, a negative correlation, or saying there is no correlation. So the word correlation means the relationship between the paired data. So it can either have a positive relationship, so as X increases, Y increases. So for instance, the more accidents, as the accidents of a car go up, the insurance likely goes up. So as one increases, the other increases. Likewise, if one decreases, the other will decrease as well. So if you have less auto accidents, you're going to have a lower auto insurance that you have to pay each month. All right. A negative correlation is that as one of them increases, so as X increases, Y is decreasing. So as your mileage of your car increases, the value of your car is going to decrease. So right here, low mileage, high value. Down here, higher mileage, lower value. Okay. So that's positive and negative. And you can notice, look at the line that we have here. The relationship is shown with a positive slope as well. And here we have a negative slope. Oops, let me move that. And here we have a negative slope. Okay, so correlation can often be, slope can be used to describe it. When something has no apparent correlation, it doesn't really, we don't really see a line that can be drawn to represent that data. So here, X and Y are not related. In this instance, it says the auto body color, so the color of your car versus the quality of the car, right? We shouldn't see much of a relationship here. You can see each of these different data points that were collected for different cars. The quality is higher for ones that, I don't even know how you quantify color, maybe on the spectrum, I don't know, I'm not sure. But, they don't really show much of a relationship. So let me go ahead and show you two little, funny scatter plots that are kind of comical. So this one says mostly positive correlation between procrastination habits. So it relates the number of chores that the person has to do versus the hours of Netflix binged. So it appears like there's a positive relationship here. Like the more chores that they have to do, the more hours of Netflix that they binge. Again, it's commenting on the joke that, the more they have to do, the more they procrastinate. It pulls this person right here. It shows this instance. I guess this could all be one person on different days, or maybe each order pair is a different person. But this person had a bunch of chores to do and didn't watch much Netflix. Let's go ahead and look at this one. This one's a little bit morbid, but you can see we have a harvester here and some people running away. So it says the head start here on the x-axis with survival time on the y-axis. So each order pair I would argue is probably a different person. Low head start, low survival time, higher head start, much higher survival time. So this is a positive relationship. I do want to point out, let's look at this point. Let me pull out a marker. Let's look at this point and this point, for instance. Right here, we have a head start of about like 28 seconds. They're surviving for about 23. This right here, head start of about 16 seconds, they're also surviving for about 23 seconds. So take note that these, we can have repeating x values or y values, or maybe even 2 points on the same exact ordered pair. So note now that ordered pairs are not going to be all a part of the same function. Okay, instead, we're going to have this line right here, which we could find an equation for, a function for this equation. Okay, so it's not all just going to be, in a straight line exactly, and then we're going to graph them. So a little bit different than what we've done in the past. So this line that I was just referring to is known as the line of fit, or the best fit line. Another word for it is linear regression. Okay, that's what mathematicians use. So this is a line used to represent the trend in data showing a positive or negative correlation. So, for instance, we have right here, it seems like as the number of missed classes increases, so a student misses more classes, their exam score seems to go down, right? These people didn't miss many classes, high scores, missed a lot of classes, low scores. So what we can do is we can go ahead and draw a line of fit that maps out this data. The whole idea here is that if we were to draw our line and then get rid of all the points, we should be able to tell what the data was telling us. So let me go ahead and try to draw a line. When we draw our line, what we should be trying to do, like I said, is to follow the trend of the data. Additionally, there's a good rule to follow is to have half your points above and about half your points below. So let's go ahead and draw this line. I feel like this is pretty good. Yeah, I feel pretty good about that. Once again, about half the points above and below. You can maybe be moved up a little bit. This seems like it's pretty good. But the idea, once again, let me go ahead and do this with the white, or I'm going to cover up all the data points. Let's do this, and I'll move my red line up after. All right, here you go. So the idea here is that this should show what our data did, even when the data points are removed. So if I go like this, all right, yeah, in fact, that does look like what our data was showing. And again, that secondary rule that we can try and follow is about half above and half below. The reason why that's not your main rule is because right now, this would be half above and half below. Well, that's a terrible line of fit. It doesn't map out what the data shows. So this looks pretty good. So as you can imagine, there are some different lines of fit that people can have, right? There's going to be a range of what is acceptable when I'm grading your assessment, and that is okay. Another little guideline that people will often use is grab the upper leftmost point and the bottom rightmost point and connect those two. And that very often, it's strange, but it does very often end up being an accurate line of fit. All right, so we're going to go ahead and turn to page 44, and what we're going to do is we're going to actually try making our own line of fit, okay? So on page 44, I do want you to make an adjustment to the page. There is no label to the X and Y, table or axes. I want you to add that because I think learning for the first time, it's better to have some context to the problem as opposed to just, doing it with random numbers. So let's go ahead and change the X. You can write this in and write it on the X axis here, is hours slept last night. Okay, so the hours slept last night will be our X, and then the score on the quiz out of 15 will be our Y-axis. So again, go ahead and write that into both your axes and on the table. So I'm going to go ahead and duplicate this and put it here, and duplicate this, and we'll put it right here. All right, cool. So let's go ahead and graph these ordered pairs. We'll talk about this break in just a second, but be aware of that when you are plotting your points. Ooh, got to change off the white. All right, so we have 0, 5, 1, 8. Let's see if I pause this. Okay, there we go. So I have plotted all my points. And one thing I'll point out to you that I didn't talk about earlier is I did add 2 ordered pairs to this. So why don't you go ahead and add those as well. I wanted to just get a little bit more points in here. And again, I'm just messing with the data. I'm changing our data set here. So here we have our data, right? Now, you do want to be careful with breaks. If we were making this ourselves, I don't know that we'd really put a break here just to skip 5 numbers, but you do have to be careful with breaks because when we are writing our line of fits equation, we do want to be careful with that. It could mess with some. So we're going to go ahead and connect our line. Let me change our color. Change it to blue. All right, so we can go ahead and draw our line of fit. Let's go ahead and do something like this. You know, this point right here is going to pull it down a little bit, not all the way down, because then we have a bunch above. I would say it comes down a little bit from here, maybe about there. Looks pretty good. So again, we have about the same amount above, 1, 2, 3, as below, 1, 2, 3. We have 1 on the line. This looks pretty good to me. So when we're drawing, or so the next step actually is that we're going to be looking to find the equation of this line of fit. Okay, we want the slope-intercept form equation. So something like y equals 2x plus 5, let's just say. So the way we find an equation of a line, we no longer care about these ordered pairs, right? We are looking for the equation of this line, and what you need for that is 2 points on the line. So we're going to go ahead and circle 2 points on our line. Let's grab, I'm going to change my color from red. Let's change it to green. So I'm going to go ahead and grab 2 points where it intersects at an x and a y point. So right here looks pretty good. This is 1, 7. And, well, actually, we could just use this ordered pair that we actually went through. So this is fine. Okay, so we have 1, 7. Write that down. And then point 2 is 6, 15. So we no longer need, like I said, we no longer need these ordered pairs. We just care about 2 different points. I do want you to circle the 2 points that you end up using. All right. So we're going to go ahead and find the slope between these 2 points, and then we're going to get it into slope-intercept form. Okay. So this is what we want to write the line of fit. So I'm going to go ahead and find the slope, like I said. So 15 minus 7 over 6 minus 1, which is going to be 8 over 5. Okay. You may have a different slope, and that is okay. I will have, kind of an acceptable range. And we'll talk about that in the class when I'm there. So let's go ahead and choose a point. I'm going to go in point slope form first and then convert to slope intercept. So we have y minus 7 is equal to 8/5 times x minus 1. Let's distribute. So we have y minus 7 equals 8/5 x minus 8/5. And then on both sides, I'm going to add 7, but over here, I'm going to, add that with a common denominator of 5. So I'm going to multiply this by 5, so add 35/5. And this is just going to get us our answer of y equals 8/5 x plus, let's see, that would be 27/5. So this is our equation in slope-intercept form. Now, one thing I would likely do, I often say that improper fractions are totally fine, but one thing that might be helpful is to see it as a mixed number. So that would be 5 2/5, because that way you can go ahead and take a look at your graph, your scatter plot, to see if that's where your equation actually crossed the y-axis. So we can see right here, this is a little bit between 5 and 6, and on this one it looks like it's at the lower end of a half, but sometimes our line is going to be off by just a tad. So yeah, this looks pretty good. This is our y-intercept. So this matches out, all right? And that's what I'm going to be looking for. So anything around this range, if you have something, maybe you have, so this is like a 1.4, I guess. If you have something around that range, 1.5, somewhere between 1 and 2, that's probably going to be acceptable slope. And something around here between, I don't know, maybe 5 and 7, for your slope, or for your y-intercept. So this looks pretty good. We'll have more that we go over after this, but for right now, you go ahead and use this line of fit to make predictions. Like, all right, well, if I slept for 4 hours, or the person slept for 4 hours, what can you expect them to get on their quiz out of 15? All right, so there you go. That is an introduction to scatterplots, and we'll obviously be doing more with this moving forward.